Okay, students, now that we know the SI unit and dimensional formula of fundamental quantities, that is 7 fundamental quantities. Now we'll start playing with the dimensional formula. That is, we have discussed the dimensional formula of the 7 fundamental quantities. Let's recall. Length dimensional formula was capital letter L. Mass dimensional formula was capital letter M. Times dimensional formula was capital letter T. Temperatures dimensional formula was capital K. Electric current dimensional formula was capital letter A. The dimensional formula of luminous intensity was CD, and the dimensional formula for amount of substance, it was mole. Now in this class I'm going to speak about the dimensional formula of some derived quantities. We'll speak about the SI unit also. That is, I'm not saying the dimensional formula of the entire derived quantity, but we'll discuss the SI unit and dimensional formula of some important derived quantities. Let's start from the basic one, that is, let's say area. Area, it is having a dimensional formula, that is, area is having an SI unit of meter square. As you all know, the SI unit of area is meter square. It's obtained by length into breadth. Therefore, the dimensional formula of area will be L square. Hope that is clear. Since area is length into breadth, length is having dimensional formula L. Therefore, L into L, that is L square. Area. Then volume. Volume is obtained by the relation length into breadth into height, L into P into H, or L cube. Therefore, the SI unit of volume is meter cube. SI unit is meter cube, and the dimensional formula will be L into L into L. Therefore, it is L cube. L cube. Then next, let's say about speed. Speed, it is distance traveled in a unit time. It is distance by time, and since it is distance by time, its SI unit is meter second raised to minus 1. Distance SI unit is meter, times SI unit is second. Therefore, taken to the numerator, it will become meter second raised to minus 1. Then the dimensional formula of speed. The dimensional formula of speed is distance dimensional formula is L times dimensional formula is T. Therefore, it is LT raised to minus 1. Speed's dimensional formula is LT raised to minus 1. Then let's go for velocity. We'll discuss about velocity in detail in our later classes. Now we'll say about the formula. Velocity is displacement by time. Velocity, it is displacement by time, and displacement is also having an SI unit of meter. Time is having an SI unit of second. Therefore, ms raised to minus 1, or meter per second, is the SI unit of velocity. The dimensional formula of velocity is same, that is LT raised to minus 1 itself. Therefore, speed and velocity are having same SI unit and dimensional formula, but they are not same physical quantity. They are two different physical quantities, but they are having same SI unit and dimensional formula. Okay. Then let's speak about acceleration. As you all know, acceleration is velocity divided by time. It is velocity by time, and since it is velocity by time, we could say velocity is having an SI unit of meter per second, or meter second raised to minus 1 divided by second. That means meter second raised to minus 2 is the SI unit of acceleration. ms raised to minus 2, or meter per second square, it is the SI unit of acceleration. Then the dimensional formula. The dimensional formula of acceleration will be velocity's dimensional formula is LT raised to minus 1 divided by times dimensional formula is T. Therefore, LT raised to minus 2, it is the dimensional formula of acceleration. Acceleration's dimensional formula is LT raised to minus 2. Then let's speak about momentum. If you are not aware of momentum, let me give you a crisp idea. We'll discuss about momentum in detail in our later chapters. If I'm giving you a crisp idea or a very short idea, momentum, it is the product of mass and velocity. Momentum is the product of mass and velocity. P is equal to mv is the formula for finding out momentum. P is equal to mv is the formula for finding out momentum, where small p is momentum, m is mass, v is velocity. Therefore, from this formula, we could say the SI unit of momentum should be mass is having an SI unit of kilogram, velocity is having an SI unit of meter second raised to minus 1. Therefore, kilogram meter second raised to minus 1, kilogram meter second raised to minus 1 is the SI unit of momentum. Clear? Then, what's the dimensional formula of momentum? What is the dimensional formula of momentum? For that, what is the dimensional formula of mass? The dimensional formula of mass is capital M. Then, what's the dimensional formula of velocity? The dimensional formula of velocity is LT raised to minus 1. Therefore, MLT raised to minus 1. MLT raised to minus 1 is the dimensional formula of momentum. Then, let's go for force. You might have learned an expression for force, that is F is equal to ma. You might have learned it in your previous classes. Force is equal to mass into acceleration. Therefore, let's go for the SI unit and dimensional formula of force. The SI unit of mass is kilogram. The SI unit of acceleration is ms raised to minus 2. Therefore, kilogram meter second raised to minus 2. Kilogram meter second raised to minus 2. It is the SI unit of force. It is the SI unit of force. Instead of writing it like this, we can represent it as Newton. This is the common way of representing the SI unit of force. The SI unit of force is Newton. 1 kilogram meter second raised to minus 2 is 1 Newton. Okay. Therefore, SI unit of forces you can write Newton, or it is kilogram meter second raised to minus 2. Commonly, it is denoted as Newton. Okay. Then let's say about the dimensional formula. If we are going for the dimensional formula of force, what's the dimensional formula of mass? The dimensional formula of mass, it is capital M. The dimensional formula of mass is capital M. What's the dimensional formula of acceleration? Acceleration's dimensional formula is LT raised to minus 2. Acceleration's dimensional formula is LT raised to minus 2. Therefore, force dimensional formula will be mass into LT raised to minus 2. MLT raised to minus 2 within the square bracket. It is the dimensional formula of force. The dimensional formula of force is MLT raised to minus 2. What is MLT raised to minus 1? MLT raised to minus 1 is the dimensional formula of momentum. Therefore, what's LT raised to minus 1? LT raised to minus 1 is the dimensional formula of speed and velocity. Clear? Then, let's speak about the next physical quantity. Let's have work. What's the dimensional formula of work? In order to find out the dimensional formula of work, you might have learned work is force into displacement. Work is force into displacement. Therefore, if we are using this formula for finding out the SI unit and dimensional formula, the SI unit of force is Newton and the SI unit of displacement is meter. Therefore, Newton meter is 1 SI unit for work. But it's denoted as joule also. Commonly, the SI unit of work is denoted as joule. The SI unit of work is denoted as joule. Therefore, let's go for the dimensional formula. For that, we can understand the formula for work is W is equal to F dot X, or force into displacement. Therefore, what's the dimensional formula of force? What's the dimensional formula of force? It is MLT raised to minus 2. Then I'll write MLT raised to minus 2 into the dimensional formula of displacement. The dimensional formula of displacement is actually length itself. Therefore, L itself. The dimensional formula of displacement is L. Therefore, if we are writing it in a combined simplified manner, it will be L into L, it will become L square T raised to minus 2. ML square T raised to minus 2. It is the dimensional formula of work. Okay, then let's speak about the dimensional formula of power. Let's speak about the dimensional formula of power. What is power? Power is the rate of doing work. Power is the rate of doing work. Therefore, power is work divided by time. Power is work divided by time. And if we are using this expression for finding out the SI unit and dimensional formula, power's SI unit will be work's SI unit is joule times SI unit is second. Therefore, joule second raised to minus 1 or joule per second. But instead of writing it as joule per second, we used to write the power's SI unit as watt. Watt. Therefore, watt is the SI unit of power. Power's SI unit is watt. Okay, then let's speak about the dimensional formula of power. What's the dimensional formula of work? The dimensional formula of work is ml square t raised to minus 2. The dimensional formula of work is ml square t raised to minus 2. Therefore, the dimensional formula of power will be ml square t raised to minus 2 divided by dimensional formula of time, that is t. Then it will become m L square is L square itself. We'll have to take this t to the numerator. Then it is t raised to minus 1 into t raised to minus 2. T raised to minus 1 into t raised to minus 2. It is t raised to minus 3. Okay. ml square t raised to minus 3. It is the dimensional formula of power. Okay. Then let's quickly recall the SI unit and dimensional formula. Therefore, let's recall the SI unit and dimensional formula. The SI unit of area, it is meter square, and the dimensional formula is L square. SI unit of area is meter square and the dimensional formula is L square. The SI unit of volume, it is meter cube and its dimensional formula is L cube. The SI unit of speed and velocity, the SI unit of speed and velocity, it is ms raised to minus 1 or meter per second, and its dimensional formula is lt raised to minus 1, lt raised to minus 1. The SI unit of acceleration, it is ms raised to minus 2, and its dimensional formula is lt raised to minus 2. Momentum's SI unit is kilogram meter second raised to minus 1. Momentum's SI unit is kilogram meter second raised to minus 1. Dimensional formula is mlt raised to minus 1. Similarly, force SI unit is Newton. The SI unit of force is Newton, and the dimensional formula of force is mlt raised to minus 2. What's the dimensional formula of force? It is mlt raised to minus 2. The SI unit of work, it is joule. SI unit of work is joule, and its dimensional formula is ml square t raised to minus 2. ml t raised to minus 2 is the dimensional formula of force, while ml square t raised to minus 2 is the dimensional formula of work. For your knowledge, you just simply remember work, heat, energy, all are having same dimensional formula. I'm repeating, work, heat and energy all are having same SI unit and dimensional formula. Okay, then power's SI unit. The SI unit of power is watt. SI unit of power is watt, and the dimensional formula of power is ml square t raised to minus 3. ml square t raised to minus 3. Let me discuss some more important physical quantities that you should remember. That is pressure. Pressure is force per unit area. Pressure is force per unit area. Therefore, by using this formula, we could say the SI unit of pressure will be Newton per meter square. Newton per meter square. The SI unit of pressure is Newton per meter square. It is denoted as Pascal. SI unit of pressure is denoted as Pascal, and the dimensional formula. If we have to get the dimensional formula of pressure, we should remember the dimensional formula of force and the dimensional formula of area. Can you recall the dimensional formula of force? The dimensional formula of force was mlt raised to minus 2. mlt raised to minus 2 was the dimensional formula of force. divided by dimensional formula. Area's dimensional